Welcome to the DIY Honda Garage channel. DTC P0341 refers to a malfunction with the Camshaft Position (CMP) sensor A and the Crankshaft Position (CKP) sensor, indicating an incorrect phase is detected between these components. This issue can potentially affect the engine's timing and performance due to the critical role these sensors play in the engine management system. The CMP sensor is typically located near the camshaft, while the CKP sensor is positioned near the crankshaft, making both pivotal in monitoring engine rotation and position. The diagnostic trouble code, DTC, is triggered when these sensors fail to synchronize their readings, which can lead to various engine performance problems and even engine stalling in severe cases. Before beginning diagnostics, it is crucial to record all freeze data and onboard snapshots for further analysis. The Honda Diagnostic System, HDS, is utilized to read the DTC and execute the necessary troubleshooting steps outlined in the manual. DTC P0341 is defined as the CMP sensor A and CKP sensor incorrectly detecting phase alignment. The CMP sensor, which monitors the position of the camshaft, plays a vital role in ensuring the engine's timing is precise. Located on the camshaft, this sensor sends signals to the Engine Control Module, ECM, to help regulate fuel injection and ignition timing. The CKP sensor, on the other hand, tracks the position of the crankshaft, vital for monitoring engine speed and rotation. This sensor is typically mounted on the crankshaft or near it, capturing its rotational speed and position to synchronize with the CMP sensor's data. When these sensors detect misalignment in their readings, it triggers DTC P0341, indicating a mismatch that can cause performance issues, irregular idling, or engine misfires. Therefore, understanding the positions and functions of these components is crucial for effective troubleshooting. Several issues can lead to the triggering of DTC P0341. One of the most common causes is a poor electrical connection, which can result from damaged wiring or corroded terminals that disrupt the signals between the sensors and ECM. Additionally, a faulty CMP or CKP sensor itself can lead to phase detection errors, meaning that either component might need to be tested for functionality. Problems with the timing chain may also contribute to this error code, as a stretched or damaged chain can throw off the timing synchronization necessary for proper engine operation. Furthermore, the variable timing control, VTC, actuator's malfunction could affect the functioning of either sensor, leading to inaccuracies in reading positions and phases. Each of these potential issues must be examined closely to accurately diagnose and resolve the DTC P0341. The symptoms associated with DTC P0341 can significantly impact the vehicle's performance. One common symptom is engine misfiring, which occurs when there is a mismatch in fuel and air delivery due to incorrect timing readings. This can lead to a rough idle, where the engine struggles to maintain a steady RPM when at rest. Additionally, drivers may notice poor acceleration as the engine fails to respond properly, making it challenging to drive smoothly. Another telling sign is the illumination of the check engine light, CEL, on the dashboard, indicating a detected issue that requires attention. If these symptoms are present, it is crucial to conduct thorough diagnostics to confirm the presence of DTC P0341 and identify the underlying problems affecting the CMP and CKP sensors. The first step in troubleshooting DTC P0341 involves several critical actions. Begin by turning the ignition switch to the on-to position without starting the engine, which allows the vehicle's electronics to engage. After this, use the Honda Diagnostic System, HDS, to clear any existing DTCs. This step resets the vehicle's computer and can sometimes resolve minor glitches. Following this, a test drive is necessary to recreate conditions under which the DTC was flagged. Drive the vehicle steadily at a speed range between 19 and 38 miles per hour for a duration of 10 minutes to collect pertinent data. After completing the test drive, it is important to check for any pending or confirmed DTCs with the HDS to see if the P0341 code reappears. If it does, proceed to the next step in troubleshooting. In Step 2, the focus shifts to evaluating the variable timing control (VTC) system. Utilizing the HDS, initiate the VTC test found in the inspection menu. This test is designed to analyze the performance of the VTC system, which is critical for the proper operation of both the CMP and CKP sensors. Once the test is completed, check the results meticulously. If the results are satisfactory and indicated as OK, it confirms that the VTC system is operating correctly, allowing progress to the next troubleshooting step. However, if the test results return no or indicate any form of malfunction, it suggests that the VTC system requires further investigation or repair, specifically focusing on the components that influence the timing and alignment of sensor operation. Step 3 involves another test drive to further assess the VTC system. Specifically, the vehicle should be driven steadily at speeds between 19 to 38 miles per hour for 10 minutes once more. This duration allows for the vehicle's engine management system to stabilize during operation, providing reliable data. After the test drive, use the HDS to check the VTC status parameters. You will need to compare the current conditions against the predetermined thresholds specified in the diagnostic guidelines. If the values do not align, repeat the test drive and recheck the VTC status. Ensuring consistent performance in the VTC is crucial, as deviations here can directly affect how the CMP and CKP sensors operate, potentially leading to the triggering of DTC P0341. In Step 4, monitoring the onboard diagnostic (OBD) status is crucial to ascertain if the issue persists. Use the HDS to observe the DTCs listed in the menu, specifically focusing on P0341. If the HDS indicates that DTC P0341 is flagged as failed, it's essential to go to Step 5 for further diagnostics. Alternatively, if the data indicates passed, you may be dealing with an intermittent failure at that moment. Thus, the system might be functioning as intended. However, if the HDS states not completed, this suggests further testing is required. Remember, ensuring the system is working correctly during this step is essential for oscillating the fault and confirming whether mechanical or electrical issues exist. Step 5 involves checking the VTC oil control valve, which is integral to the timing control system. This solenoid valve regulates the flow of oil to the VTC system, affecting how timing adjustments take place based on engine performance. To test the operation of the VTC oil control valve, you'll need to ensure it activates under the proper conditions set forth in the diagnostic procedures. If the solenoid works correctly, it suggests that the control mechanism is functional, allowing you to proceed to evaluate the camshaft timing in the next step. Conversely, if the valve is found to be defective, it should be replaced, and thereafter, a repair verification must be conducted to ensure the problem has been resolved and the DTC no longer appears. The focus of Step 6 is to verify the integrity of the camshaft timing, which is critical for ensuring proper engine operation. A misalignment here can lead to a cascade of issues, including the triggering of DTC P0341. During this check, you'll need to ensure that the camshaft timing aligns perfectly with the crankshaft timing specifications. If the timing is verified as correct, you can safely proceed to Step 7. However, if discrepancies are noted, resetting the timing is necessary to ensure synchronization is restored. This resetting process may require specific calibration steps to avoid further errors in timing, which is crucial to engine performance. In Step 7, the cam chain's condition is scrutinized as part of troubleshooting DTC P0341. The cam chain's role is essential as it facilitates the connection between the crankshaft and the camshaft, allowing for synchronized movement. Inspecting the cam chain for signs of damage, such as wear or breakage, is crucial. Additionally, checking for stretch is critical, as an excessively stretched cam chain can disrupt timing. If damage or stretch is present, replacing the cam chain along with the auto tensioner is advisable to restore timing accuracy and engine performance. Conversely, if no issues are found, you will proceed to Step 8, indicating that the timing mechanism is functioning appropriately. Step 8 focuses on inspecting the VTC actuator, a vital component that affects the timing control of the engine. The actuator works by adjusting the position of the camshaft based on the input it receives from the ECU, which is influenced by engine demand. To proceed, inspect the actuator for signs of failure, blockage, or wear. If the inspection reveals that the actuator is functioning properly, it's a positive indicator that the timing mechanism is intact. However, if any issues are discovered during this inspection, replacing the VTC actuator will be necessary to correct the problem. Once this is done, conducting a repair verification will solidify the repair process, ensuring that the DTC does not reoccurrence. The final troubleshooting step, Step 9, centers upon resetting the powertrain control module, PCM. Begin by switching the ignition to the on position without starting the engine. This action allows the HDS to communicate effectively with the PCM. Next, execute a reset of the PCM using the HDS, which clears the previous data stored in it, including any error codes that might be influencing performance. Following this, complete the PCM idle learn procedure, which calibrates the PCM to recognize new baseline operating conditions. Additionally, perform the CKP pattern clear and CKP pattern learn procedures to ensure the crankshaft position information is correctly recognized by the PCM. Afterward, conduct another test drive at speeds between 19 to 38 miles per hour for 10 minutes, followed by checking for any pending or confirmed DTCs. If the P0341 DTC is still indicated, further investigation into the electrical connections and terminals related to the VTC oil control solenoid and PCM is necessary. Once all troubleshooting steps have been completed, it is crucial to perform a final repair verification to ensure that the DTC P0341 has been resolved. Start by turning the ignition switch to the on-to position. Utilize the HDS to reset the PCM once more before proceeding to do the PCM idle learn procedure to calibrate the engine's idle behavior effectively. Following this, complete the CKP pattern clear and CKP pattern learn procedures to synchronize the crankshaft readings correctly. After conducting these procedures, test drive the vehicle again under the prescribed conditions of 19 to 38 miles per hour for 10 minutes. Lastly, monitor the OBD status for DTC P0341 within the HDS. If the code indicates passed, it affirms that the issue has been resolved. However, if failed or not completed appears, further diagnostics will be necessary. Preventive maintenance is crucial to minimize the risk of encountering DTC P0341 in the future. Regular service checks should include inspections of the CMP and CKP sensors to ensure they are functioning correctly and that their connections are secure. Additionally, monitoring electrical connections for signs of wear, corrosion, or damage can help prevent issues related to poor signal transmission. It's also vital to keep an eye on timing components, such as the cam chain and VTC actuator, to ensure they are in good condition. By maintaining these parts, you can help ensure accuracy in timing signals, which significantly contributes to the overall health of the engine. Implementing these preventive strategies can lead to improved engine performance and fewer diagnostic issues. In summary, DTC P0341 indicates a misalignment between the CMP sensor A and CKP sensor regarding their phase detection. The troubleshooting process involves a series of steps that range from simple checks like verifying electrical connections to more complex investigations, such as inspecting the VTC system, camshaft timing, and associated components like the VTC oil control valve and actuator. It is imperative to perform these checks meticulously to identify the root cause effectively. Maintaining these components through regular diagnostics and preventive maintenance is vital to prevent the recurrence of such issues and ensure smooth engine operation. Ultimately, addressing DTC P0341 promptly and thoroughly can lead to enhanced engine performance and reliability. Please like and subscribe to the channel. See you next time.